Today, I'm going to introduce you to a very special LTX video workflow. Let's take a look at the final result first.
The sky is crying blue, there's a way for you. The fire in my heart, burning white and true. 1,000 miles, the smoke is rising high both sides. I see your shadow outlined through.
As you might have guessed from seeing the video, this is an S2V workflow. That stands for sound to video. Essentially, we are generating video based on audio input. The core feature of this workflow is that we start with a piece of audio and we generate a matching video for it, specifically aiming for a precise lip sync effect. I have prepared two versions of this workflow for you. The first one is designed to run on low VRAM, primarily using GGUF models as the base. The second workflow runs on standard models. Regardless of which model you choose, the basic structure and process of the workflows are essentially the same. Now, let's analyze this workflow. I've uploaded it to RunningHub, so you can access it through runninghub.ai. In the ComfUI space, RunningHub is a fantastic online workspace because they update with new models and extensions as soon as they are released. You can register using the invitation link in the video description to get 1,000 free credits. Plus, logging in daily gives you an extra 100 points, so you can try out these workflows yourself. Regarding the overall structure, I covered a lot of this in the previous video, so if you're unsure, go check that out. I'll just briefly highlight the most critical parts here. First, this workflow uses a single sampling stage. There is no upscaling part. We are directly generating a video at 1280 by 720. You can see the configuration here for width, height, and frame rate. The most important part of this workflow lies in these specific models. Pay attention here, our main model and text encoder are loaded using GGUF nodes. If you want to use these nodes, you need to install the GUF extension and make sure to update it to the latest version. Next to this node is actually from the native ComfUI workflow. We are loading the video encoder. Then we have this node developed by Kijai. Its main function is to load the LTX video audio encoder. Note that the sources for these models are quite different. The first three are provided by Kijai, but for the encoder at the back, we downloaded it from a specific repository. I'm using a specific version here, the Q4 quantized version. The reason is that our main model is also a Q4 quantized version, so we want to keep them consistent. You can find the three Kijai models in the diffusion models folder. For the main model, I'm using a distilled Q4 quantized version. For the VAE, notice this. Just about 4 hours ago, Kijai re-uploaded a new version of the video encoder. Then we have our embedding connector. This isn't the main encoder, but an embedding connector. And we are also using the distilled version. I strongly recommend reading the model card. There's a huge importance tag there. It highlights that the old version of the VAE had significant issues, which is why he updated it. He also explains the basic usage of these nodes. Although he isn't using GGUF models in his example, he includes a very crucial note about GGUF. His loading method works with GGUF models, but only if the GGUF model contains metadata. If you're wondering what metadata is, think of it as the instruction manual for the model. It contains basic architectural info, like what kind of model it is, as well as hyperparameter configurations like the number of layers, attention heads, embedding dimensions, and context tokens. It also includes quantization information. So, having this metadata is essential. I won't go into too much detail on the sampling part, but I want to emphasize two things. First, my sampling steps are set to 8 because this is a distilled model. Similarly, the CFG must be set to 1.0. For the sampler, I suggest choosing LCM. Other than that, standard settings apply. Here is the video latent generation part. We have a reference image, we generate an empty latent, and then we inject the image into it. That's the basic idea. Now comes the most critical part. In previous workflows, the audio latent was just generated as empty. Today, we are loading an actual audio file. This audio is quite long, 33 seconds. I'm going to clip a section from the middle, let's say a 5-second segment. We use the audio encode node to encode this into the latent space. Then, we generate a solid mask and set the mask value to 0. We connect this mask to a node called setLatentNoiseMask. If you do in painting, you're likely familiar with this node. After this, we get an audio latent. We connect it directly to this node that combines audio and video to generate the final latent, which then goes into the sampler. Let's listen to the audio clip.
The sky is crying blue, is a way for you.
Many people add another step here, separating the vocals from the background music. If you want to do this, the standard approach involves using a separation node. The output gives you vocals and accompaniment separately. It requires downloading a specific model. Once that's separated, you would just connect the vocals output to the LTX Audio VAE encode node. To use these nodes, you need to install Kijai's specific extension. You can see it here. Installation is simple, and the download links and paths are provided. I didn't do this for my current demo because, as you heard, the audio track I'm using doesn't have background music. Let's look at the result after sampling.
The sky is crying blue, is a way for you.
I think both the audio and video quality are excellent. The lip sync performance is particularly impressive. The fit between the mouth movements and the sound is very high. I ran several tests. For the second test, I took the next 5 seconds of the video to generate another clip.
Fire in my heart, burning white and true.
It looks very beautiful. For the third workflow test, I used an Asian character model.
As the smoke is rising high both sides.
You can see the lip shape and the overall video-audio sync even more clearly here. And here is the final example.
Well, light through. The sky's still dark as I.
After testing so many instances, it is clear that this model's capability in this specific area is very strong. You might have noticed a pattern. I used one long audio track but split it into 4 segments to generate 4 separate videos. Naturally, I want to combine them into one complete video. You can do this with any editing software. Let me show you. I'll drag the videos onto the timeline in order. If we just play them back, you'll notice a problem.
The sky is crying blue, is a way for you. The fire in my heart, burning white and true. 1,000 miles, the smoke is rising high both sides. I see your shadow outline through.
The transitions between the clips aren't natural because they were generated separately. Here is my recommendation for fixing this. Take your generated video clips into your editor, but detach and delete the audio from them. Then, bring in your original full-length source audio track vocals or music included, and align the video clips to that continuous track. Trim the clips where necessary to make it seamless.
The sky is crying blue, is a way for you. The fire in my heart, burning white and true. 1,000 miles, the smoke is rising high both sides. I see your shadow outline through.
This creates the final effect you saw at the beginning. I also built a version of this workflow on RunningHub that uses standard models, not the GGUF versions. This is because RunningHub doesn't currently provide the best GGUF support for this specific setup, though they have the main models. The VRAM usage can be an issue here. So I swapped it for the standard model. I also added the background music removal feature to this version. For sampling, I used CFG 4.0 and 20 steps, sticking to the official recommendations. However, let's look at the result.
The sky is crying blue, is a way for you.
Honestly, I don't think the result is as good. Visually, it looks a bit blurry. This might be due to the reference image, but it's why I strongly recommend using the GGUF models and the distilled workflow I showed you earlier. It's pretty magical, right? What are you waiting for? Go give it a try yourself. Don't forget to follow me to stay updated on AI technology.